A brief monologue from somebody who would like you to learn physics. So, in every class that I've had over the last couple of decades, some problems have become just about standardized in their nature. And these are some of the things that I see that students will do that hinder their success. They prevent them from understanding the material and doing as well as their intellect would indicate they should do. So, my top 8 physics sins, if you will. Number one, they rely on equation sheets. And I understand sincerely that many physics students, particularly in high school, are not necessarily there to learn physics, but maybe they're seeking a particular type of diploma. Maybe it's necessary if they're an undergrad to achieve the degree that they want, but they don't see it as relevant. I understand that. Um, if you're in AP, you're making the argument that, well, they will give us an equation sheet to use on the exam, and there are two problems with that. The first one is if you are using the equation sheet on the exam, it has slowed you down. And the second reason is that knowing the equations means knowing the relationships between the variables in a system. And it is our understanding of those relationships that underlines comprehension of that system. So knowing the equations is to know the relationships, is to understand the system. True comprehension comes with knowing the system. Know those base equations. The base equations, they underline the foundation of what we're trying to do here. Know them. Don't rely on an equation sheet. Don't waste your time looking at it. When you read a problem, you want to have several base equations pop into the forefront of your mind immediately, just when you look at a particular problem. You jot those down in the margin as you're reading through the problem, and you have already developed a starting point for a solution. So don't rely on equation sheets. And finally, if you are one of the fortunate few who are in my class, you will not get one of these on our assessments. You don't get an equation sheet in our class. So, on the day of the test, you're not going to have equations handed out to you on a piece of paper. You will know them or you will not. So, that's probably the first mistake. Don't do that. Commit those base equations, the fundamental relationships to memory. So, that's the first um, shortcoming that some students will approach the class with. Um, most of us, most of you guys in physics are really far too smart to do that. There's no reason you shouldn't succeed at this with your level of intellect. So don't take the shortcut. Memorize those equations. All right, the second thing that they do that is problematic is they manipulate numbers and not equations. EQNS for short. All right, so they manipulate numbers instead of equations. Don't do that. Don't manipulate numbers, manipulate the equations. And here's what I mean by that. Just randomly, let's say that a student knows V naught, V, and X. Let's just make up some random numbers here, maybe 20 meters per second, 60 meters per second, and I don't know, 200 meters. And they are looking for the acceleration of a particular object. And they wisely choose v squared is v naught squared plus 2ax. That is a wonderful place to begin. When you're doing kinematics, if you know the base equations, refer to number 1. Then you have already jotted these down as you're reading through the problem. So good place to start. But then they'll do something like this. They'll say 60 squared is 20 squared plus 2a 200, and then they'll start shuffling around these numbers trying to solve for a, which is wonderful if you're in a base algebra class and you're trying to solve for that particular variable. Yes, I understand you may be looking for this variable, but let me explain why we don't want to do this in physics. No, don't do that. What we want to do is we want to start with our base equation, manipulate it, and show your steps in your manipulation, at least in the beginning as you're learning how to do this. And once you get it to its final form, where you can now say that A definitively is equal by v squared minus v naught squared over 2x. Now it's okay to substitute your variables in and solve for it. And the reason that you want to do this first is because of derivations. Many times, particularly on the exam, you are asked to develop an expression for some variable in a particular system, and you won't be given numbers to use. You will have no definitive values to use, no quantities. You'll be given instead H or G, um, F for some force rather than a number of newtons or a particular velocity or this many meters displacement. You'll simply be told, develop an expression for this variable in terms of these other physical constants and um, algebraic variables rather than numerical variables. In that case, it's really good to be able to manipulate equations, to substitute, to solve systems, that type of thing, and not use numbers. You're deriving expressions that can be generalized to any system that fits that particular set of variables. So don't manipulate numbers, manipulate equations. Get your equations into their final form, then substitute numbers into it. That will help you develop the mode of thought that you need to dominate those derivations. It's shocking at how few numbers the exam seems to actually ask for anymore. So pay attention to that. That'll help you with your derivations. Number 3. They sometimes present work with pretty glaring omissions. And let me show you some examples of, at least mention a few examples of this. So these are simple things that every bit of work that you submit to an instructor, to a colleague, to a publication, you're really going to want to not have these glaring omissions. For instance, perhaps you have given a quantity with no units of measure. That's childlike in its severity. Don't do that. Perhaps you have stated a vector without a direction. No direction. Oh, poor little vector. It has no direction. Now it's just a lonely scalar. It's been demoted in the world. Don't do that to a vector. Love your vectors. Um, these are telltale signs of somebody who is not paying attention to the details or is simply not putting forth the effort necessary or demanded of this particular endeavor. Don't make those glaring omissions, guys. Those are the simple ones. Don't leave them out. Um, Number four, they will submit solutions um, that don't have the work present that produce that solution. So submitting solutions without the work that produced them. Um, and here's why that's a bad thing. The first one is it typically will make your instructor believe that, well, you didn't do any of the work. You simply got your answers from a colleague and wrote them down, or something along those lines. That's the first reason you don't want to do that. The second and more important reason is because if your instructor is worth their salt, they will evaluate the work that you submit and they will attempt to return it to you with some feedback that can be useful. But if you don't show the work, they can't tell you what you're doing well and what you need to improve upon or what errors were made in reaching a particular solution. So essentially, it's worthless. It's like having a list of boxes and you're going down and checking them off for no reason other than to check them off. Without the work, um, you get no valuable feedback. And the final reason why that's a bad idea, on the AP exam itself, and the way that I structure my exams are heavily tilted toward that work. Um, it is common to see an AP free response problem, say it's worth 15 points, and 1 or 2 points is for a correct solution with units, and the rest of it is all for the work that goes into producing that solution. So you must show all of your work for these reasons. Number five, um, they fail to recognize problem sets as the premier I don't know if there's an E on there or not, the premier learning tool for physics. Learning fool. It is late and I am not thinking properly. For physics. Okay. Those problem sets, they are invaluable, guys, for learning this. If you truly want to learn it and you want to understand it, or if you truly just want to dominate the AP exam, those problem sets are the most valuable thing that you can spend your time on. The effort to solve them is extraordinary in its ability to form neural connections in your brain. Even if you don't look at physics again the rest of your life after this class, you will develop a really supreme functioning brain by attempting to solve these problems. That's first thing. The second one is the feedback that you get from those problem sets. If you use them properly, everything that you did on a particular problem set that is incorrect, you must rework until you have the correct solution. You must know, what did I do wrong? Where exactly was the error made, and how do I fix it? So the effort to solve the problems, and the invaluable feedback that comes with them are really paramount to understanding the material. So problem sets, they are extraordinarily important. If you shortcut them, you're cheating yourself. Number 6, they attempt to learn physics in a vacuum. That one's that one is really common right now, and it's too bad that we're uh, stuck during this pandemic, and so many students are at home by themselves. A learning community, particularly in challenging material, is very useful. And there are always a couple of gung-ho kids in each class who sort of go it alone, do the lone wolf thing, but they're really shortchanging themselves, guys. Vacuum learning. If you're sitting at home by yourself trying to figure all these things out alone, or worse, searching the web looking for help, um, it is problematic. The best thing you can do is have a small study group, a couple of friends, a couple of colleagues in the class who you can work with, who you can solve your homework problems with, who you can study with. Yeah, it doesn't matter if you all work together to solve your homework, as long as the goal, the objective of that small group is that everybody in the group understands the solution to that particular problem. That is paramount. So don't try to do this in a vacuum, guys. Don't try to do it by yourself. It's best with colleagues, I assure you. Number 7, they submit work that is difficult for their instructor to evaluate. And there are a few reasons that it can be difficult to evaluate. The first one is if the work is chaotic. Say it's a piece of paper that looks like a bunch of chickens walked through some ink and then across your paper. It's extraordinarily difficult to figure out exactly what the student's thought process was, and how they approached the problem, how they arrived at their solution. And sometimes it can be even difficult just to find the solution, or the errors that went into producing an incorrect solution. So if you are like I was as a student, where you'll take uh, several attempts at a difficult problem and go through 2 or 3 pieces of paper, and scratch things out, and doodle while you're thinking, and that kind of craziness. Look, when you finally do arrive at a solution, get it all straight in your head and recopy it onto a fresh document so that it is legible and orderly. Um, that's going to help the instructor know what you were thinking, how you arrived at your solution, point out any errors that you made, and provide really relevant feedback that you can use to further your comprehension. Um, Another reason why you don't want to do that is because if the instructor has to waste their life searching for your solutions in the midst of a chaotic document, a chaotic paper, um, it really starts to grate on their nerves. Now, bias is inherent in all human beings. So, try not to annoy the people who are grading your papers. We certainly go through a conscious effort not to become biased, but when a student annoys us again and again and again, despite repeated attempts to get them to be a little bit more organized, After a while, you reach the conclusion that the student doesn't care, and that's problematic. So don't do that. Um, Turn in your work that's neat. Copy it over again if you have to. Make sure the solutions are easy to find. Hey, it's a good idea to draw a box around your solutions. That can save the instructor a lot of time. They can see the work that went into it. They can see your solution. If there's an error, they don't waste any time in knowing that and then backtracking and finding the fault. So do that. And then there's the last one. This video has, I apologize, it's become a bit of a rant, but this is the last one. And this is the biggest one, the worst physics sin of all. They do a web search for problem solutions. Now, this wasn't a problem when I was learning physics back in the Stone Age. I'm about 1,200 years old. So the internet wasn't an issue. And you either solved your problems or you did not, and you lived and died in the physics world by your own merit. That's not the case anymore. There is no textbook, there is no available resource older than a few days that some smart aleck grad student has it solved in its entirety and posted somewhere on the internet. I can copy and paste any textbook problem into a search engine and have solutions in seconds. You guys already know that. That's very obvious to see from some of the work that I have received. Um, that is a horrible mistake. And the first reason is because there is a lot of really useful learning material out there that once it's corrupted like that, it's worthless, and so no student will get the benefit of it. The second reason is it does force your instructors, at least those who care even a little, to spend a great deal of their own time developing a lot of things like problem sets and multiple choice questions that they really shouldn't have to spend that much time on. That material's been around and been useful to us for 70 years in this type of learning environment. Well, the internet has killed that. The third reason is you're not learning, you're robbing yourself. You are I know this sounds like the argument against cheating that's been in existence since education has been in existence. Don't cheat, you're only cheating yourself. That's not what I'm talking about here. What I'm talking about is you're not going to learn the material, you're not going to do well on the exams. If you're in my class, the exams are heavily weighted, and so you can dominate the problem sets and get every single point and have amazing solutions, and then bomb horribly on the exam and not do very well in the class at all. Um, and if you're hoping to pick up that passing AP exam score, that's not going to happen. So that would be the last one, the web search for solutions. The internet, we used to look at it as an invaluable resource of data, but yeah, sometimes we misuse it. Wonderful tool that it is. So these are my 8 physics sins that particularly new students do, or bad habits that they sometimes develop. They rely on equation sheets instead of memorizing. They manipulate numbers instead of equations. That hurts them when they go to derive expressions. They make the childish mistakes of things like no units, no directions. They submit solutions without the work that produced them. They sometimes don't see the problem sets as the valuable tool that they are. Uh, yeah, guys, if you have an instructor who's killing you with 30 problems a night, that's a problem. Okay, that's a burden that no student can bear and have time to live. Um, but 2, 3, 4, 5 problems on a regular basis is actually a quite a normal burden to bear. Um, Take that for what it is. Don't do it in a vacuum. Get some friends, get some colleagues, and learn this together. Don't make it hard for your instructors to evaluate your work. That doesn't help anybody. And then the last one, stop trying to Google your solutions. Do you really think your instructors don't know? Okay, that's it for now.